welcome to Evirtuallab.com, virtual laboratory for chemistry practicals. You could also join us and practice the experiments yourself on Evirtuallab.com. Today, we are working on redox experiment. Redox reaction is a reaction between two substances where oxidation and reduction occur simultaneously. To start the experiment, we click on Redox on the left-hand side of the screen. And then it brings us to the laboratory. We enter the laboratory and then we are ready to run the redox experiment. So to run experiment 1, this is our work table. So it gives us the data. Our pipette volume is 25 cm cube. Our acid weight is 6 grams. Our total acid volume is 500 cm cube. And our reaction equation is written below. To carry out the experiment, you may do well to click on the instructions that will guide you on the steps to follow. You do well to record these steps so you could have uninterrupted procedure. For this reaction, we are using ethanediol acid as our acid and potassium manganate 7 as our alkali. We will prepare the alkali first and then proceed to prepare the acid for the titration. For this experiment, the first step from here is to bring out our burette. So we'll bring out the burette. So to bring it out, you click on burette and then you click on your work table. The burette will appear there. And then you place a funnel for us to pour the alkali neatly into the burette. Then we come to a potassium manganate 7 bottle, click on it and bring it to the work table by clicking on it. It will fill the burette. Let us patiently wait for it to fill the burette. Now it is full and the bottle is taken out. Let's remove the funnel from the burette by clicking on remove funnel and then click on the work table to take out the funnel. Next, we will bring out a beaker. We need to run out the excess alkali in the burette. So bring the beaker, place it under by clicking on the work table, and then you go to your right hand side, click on run burette for that action to be initiated. Then click on the work table and it is initiated. The excess alkali will be taken out and then left at the 0 mark of the burette. Then we'll take out the beaker, click on remove beaker and click on the work table to remove the beaker. Now we'll set aside the alkali. We are done with preparing the alkali. So let us prepare the acid. We'll bring out the beaker containing the ethanediol acid to the work table. And then we'll take our pipette to take out 25 cm cube of the acid. We need to discharge that 25 cm cube of the pipette volume into a conical flask. So we bring the conical flask to the work table and the content is emptied into the conical flask. For this experiment, we'll need to add some more acid to prepare it for the titration. So we'll take our funnel. So we could pour the acid. So we'll take the acid bottle to the left-hand side. Click on the acid bottle and let's pour some acid into the conical flask. When that is done, we'll take out the funnel click on remove funnel, and then it is taken out. Then we need to heat this mixture in preparation for the titration. Please note that no indicator is needed for this experiment. So we heat by bringing out the Bunsen burner. Click on the Bunsen burner and bring it to the work table by clicking on the work table. Then we need to ignite. Click on fire to ignite the Bunsen burner. So we will allow it to heat for a while, and then we'll take out the flames by clicking on quench. So we quench, take and bring it to the work table. The flame is put off. We remove the conical flask by clicking remove conical flask. And then we'll also take out the Bunsen burner by clicking remove Bunsen burner, and it's taken out. We are now ready for the titration. So we click on titration. And it is set up once we click on start. So the titration has begun. So we will watch carefully until we have a color change. Please keep your cursor on the stop button so that once there's a color change, you can ask it to stop by clicking on that button. Okay, so our first titer value is 23.166 centimeter cube. So we'll go to the second run. For every experiment, you are expected to have 3 titer values, and then you take an average that you use for your calculation. So let's run experiment 2. We're going straight to the titration. So we'll start. Click on start. The titration has begun. Please observe the color change and click on stop once you observe the color change. For all the experiments, you will observe that you may not use time to get the titer value. So our second titer value is the same, 23.166 centimeter cube. So we'll go to the final titer value. We'll run experiment 3. Okay, so we have our third titer value, but we can only see the last titer value when we click on show results. So when we click on show results, it gives you all the values and then gives you the values to calculate for. Oh, so we have the same in all 3. So we take an average. So the same. So the average will still be 23.166 cm cube. So we have 23. So you're going to impute the values. 23.166 as the average titer value, and then the pipette molarity. Okay, so we have imputed our average titer value, and we are required to calculate the pipette molarity, burette molarity, our potassium manganate 7 mass concentration in grams per dm cube, and we are also required to calculate the carbon 4 oxide volume in liter. So we have done the calculation. You can find the formula to use for your calculation on evirtuallab.com. You click on contact us and then click on the manual, and you will find all the steps and what you require to complete the experiment successfully. From our calculation, we have 0.133 as our pipette molarity. Remember, in the pipette, we had the acid, and then in our burette, we had the base, and we have 0.359 as the burette molarity. Then for our manganate concentration, we have 56.72 grams per dm cube. And then finally, we have our carbon 4 oxide volume to be 0.149. So after imputing your calculated values, you click on submit. So let's submit and then see the results. So we'll print our report. So here we have all the students' details. Glory Precious is the student. And then we have the standard, what was given, the data given. Then the actual, what is expected at the end of the experiment. These are the values expected for the titer value and all the calculations. Now the student, this is the student experiment that gives you the calculation, comparing the student's calculation with the actual. And then here we have our average titer value, 23.166, but the actual is 22.523, which is given here. And then we have a percent error of 3%. Expected pipette molarity is 0.133, and we got 0.133, so we have 0% error. For burette molarity, expected it's 0.37, and we have 0.36, also 3% error. And then for the manganate concentration, expected is 58.45, but we have 56.836, also a 3% error. Concentration of the volume of carbon 4 oxide produced, expected 0.149, and then calculated is 0.149. Now in this segment, you have the student computed results. So the system has helped to compute the results from the three titer values, having the average. So if the student makes any mistake, you would see the error from this last segment because it compares what it has here with the student's experiment. So this last section is to compare how well the students understood or understands the formula to use. I hope you enjoyed our session. For more practice, please visit evirtuallab.com. Thank you.